Hello and welcome to the AI Engineering Podcast, your guide to the fast-moving world of building scalable and maintainable AI systems. When ML teams try to run complex workflows through traditional orchestration tools, they hit walls. Cash App discovered this with their fraud detection models. They needed flexible compute, isolated environments, and seamless data exchange between workflows, but their existing tools couldn't deliver. That's why Cash App relies on Prefect. Now their ML workflows run on whatever infrastructure each model needs across Google Cloud, AWS, and Databricks. Custom packages stay isolated. Model outputs flow seamlessly between workflows. Companies like Whoop and 1Password also trust Prefect for their critical workflows, but Prefect didn't stop there. They just launched FastMCP, production-ready infrastructure for AI tools. You get Prefect's orchestration plus instant OAuth, serverless scaling, and blazing fast Python execution. Deploy your AI tools once, connect to Claude, Cursor, or any MCP client. No more building auth flows or managing servers. Prefect orchestrates your ML pipeline. FastMCP handles your AI tool infrastructure. See what Prefect and FastMCP can do for your AI workflows at aiengineeringpodcast.com/prefect today. Your host is Tobias Macy, and today I'm interviewing Stephen Huels about the benefits of small language models for production workloads. So, Stephen, can you start by introducing yourself?
Hey, thanks, Tobias. Thanks for having me. So I am Vice President of Red Hat's AI engineering organization. So I'm responsible for product strategy and engineering around our AI offerings in the market.
And do you remember how you first got started working in the ML and AI space?
I do. I remember because it basically happened right out of college. So I was hired right out of university, primarily as a data warehousing consultant. And so in that endeavor, a lot of our efforts were really focused on preparing data for analytic purposes, right? And this was pre-generative AI. So this was the classic predictive AI stuff, right? That everyone knows, like the fraud detection, the regression analyses, things like that. And as you saw, or as I saw sort of the outputs of my work and how it was helping companies and just the amazing things that analytics could actually produce, I just got more and more interested into it, right? And I had plenty of opportunities to work on these kinds of projects. So when the opportunity to join Red Hat came along and get deeper in the actual practitioner space, I jumped at it.
Now, as you mentioned, generative AI has become the predominant technology that people think about when somebody says AI, even though it is not the entirety of the space. And within that overall ecosystem of generative AI, large language models and these frontier models in particular have gained the most airtime. But as we're going to be discussing today, language models come in multiple different sizes for multiple different use cases. And I'm wondering if you can just start by giving your heuristics as far as how you think about the dividing line between small language models and large language models.
Yeah, this is a good one because it's actually a bit of a moving target, right? When you look at the models that have been produced since ChatGPT launched, which effectively marks kind of the launch of generative AI from a general public mindset perspective, the size of these models has really advanced a lot, from things just being like pure as a service frontier models to then like derivatives of those models being, in much smaller parameter sizes. And as models were advancing, you also saw similar advancements in hardware that was going to be able to support these, the accelerators used for both model production and inference, and then the software supporting them on the inference side of things. So when I look at like what's a large model versus what's a small model, I tend to base it on what will fit into the footprint of a single enterprise grade GPU. And anything that would fit into that single enterprise grade GPU, I tend to consider a small model, because that's a model that if you're an enterprise looking to support a specific workload, you don't have to necessarily get into the complexities of networking and load balancing and resource sharing, right? You can stand that model up, single inference server, GPU, and start to play around with it. Larger models, right, definitely include those frontier models, but extends to anything that's going to require multiple GPUs to serve and inference that single model. And again, this continues to shift, so it's tough to say what number of parameters constitutes a large model versus a small model. We've gotten to the point today where like even a 5 billion parameter model can run on a data center grade CPU as well, right? It's not going to be quite as performant as a GPU, but it'll fit and you can actually work with it. So it tends to move. And I think we're going to continue to see this as these advancements happen in hardware and accelerators and software, where like what now is considered a large model and spans multiple GPUs will ultimately here fit into a single GPU.
Particularly as they keep stuffing more VRAM into those GPUs.
Exactly. Yep.
One of the interesting elements of your description there of it being determined by the capacity of a enterprise grade GPU, so something that you're not going to have attached to your laptop or your desktop, is that it perpetuates this trend that we've been having for the better part of the last decade plus from the software development perspective, where it is becoming more and more difficult to be able to have a full local environment for being able to do development and reproduction of your production systems. And I'm wondering how you're thinking about that as well as people are coming into this AI engineering space of, I'm going to select a model. I want to be able to do some early experimentation with it, understand its capabilities, understand how it fits in the overall system architecture, but I can't actually run it on my laptop. I need to be able to go and rent a GPU in the cloud somewhere to be able to actually use the model that I'm going to be using in production. Obviously, there are various service providers for being able to run these models as an API on a consumption-based basis, but it still adds that extra bit of friction of I have to hand out a credit card before I can really get started. And I'm wondering how you think about the translatability of the models that can actually run on a laptop or a desktop without having to spend thousands of dollars on a custom rig versus the capabilities of the model that you're actually going to be using in production, and how much of an actual real sense of the production system you can get before you actually run it in that production environment.
Yeah, this is a great one. And this is like a paradigm I see a lot of enterprises struggle with. And frankly, like even like within my organization, we've struggled a little bit where exactly what you said, like the thing that's most accessible to the developers and AI engineers today is their laptop. But a lot of times when it comes to generative AI and AI, like all these things are experiments, right? And so you're trying to run an experiment to prove a hypothesis to determine if there's viability or value in what you're doing. And sometimes, like when you start with your laptop, there are techniques today that can give you sort of an analog for how the model is going to perform, right? Whether it's QLoRa or these other sort of low fidelity type ways of working with models. But if you're not sure your idea has promise, sometimes starting with the smallest model and then using kind of a scaled down version of it isn't going to allow you to test the art of the possible to determine if there is value in moving forward. So you might actually be leaving really great ideas on the floor. The corollary to that is exactly what you said. So like, let me go start with the largest and best frontier model, but that has dollars associated with it, right? And allocating budget and getting friction and all that kind of stuff can kind of slow that thing down. So what I've tend to advocate for now with my teams, and we've been through multiple cycles of this, is if you have an idea or hypothesis that we want to try out and prove that there's potential value for, so something generally new that we haven't, it's not a refinement in an idea we already have. My guidance has been like, go start with the biggest and baddest and best model out there. We can absorb a little bit of the cost, but better to start with the best model to determine if the idea and experiment actually has value, and then try to scale it down from there into smaller models to figure out kind of where that right size, that Goldilocks zone fit is for your specific use case, than to try to start with smaller models and iterate in such a way that you don't get to a viable result. So far, this has worked pretty well for us on being able to determine pretty quickly if an ideal has merit and then moving it down to smaller models there, because it needs to be something a little bit more tailored to our use case and before we start tuning things. So that's generally the way we're kind of looking at how these things work. Like obviously there's problems though also like with large scale models. If I'm attempting to solve a problem that's specific to my business, something that the data wasn't in the public domain that these frontier models could have been trained on, it may not be a valid experiment, because how could it answer something about my specific customer base or my financials or something specific to my enterprise? So there's trade-offs in there. Good news is there's plenty of customer data and product data and other financial data like generally available that these models have been trained on, that you can kind of tailor your initial experiment to kind of again use that as an analog for your specific use case. But that's the direction we're headed right now. There's just as much development happening on the developer toolkit side of things, though, to make model development and local like laptop development more accessible. you're also starting to see like increased power in these laptops and price points coming down. So again, it's being attacked from kind of both angles. And like I'll say where maybe 2 years ago, there was maybe one individual on my team that had a laptop powerful enough to work with these models. I'd probably say 20% of the team now has access to those kinds of resources. So it's going to be solved from both directions. But right now, like starting this direct with this kind of technique has led to better results for us.
The other interesting aspect of selecting a model that is potentially self-hostable, whether on your laptop or in a data center, and not just using some service provider and consuming the model via an API, presumes that you're going to be running that model in a context where you don't have access to those API providers, which then requires a certain amount of operational and organizational sophistication to be able to even manage the actual deployment and care and feeding of these systems, because they are very simple to get a proof of concept, but in order to have an actual production grade capacity to be able to run these models and deploy new models and fine tune and monitor the models, there are a lot of other moving pieces beyond just, can I stick it in a Docker container and launch it into my Kubernetes cluster? And so I'm wondering if you can talk to some of the ways that teams and organizations should be thinking about their overall capacity before they embark on the process of determining what is the actual right open weights model or model that I want to customize. And maybe they should just use an API provider because that hides a lot of the inherent complexity to the problem space.
Yeah, this is, I think, at this point across enterprises, right? Every company knows they should be doing something with AI. And sometimes that leads to exactly what you're saying, like, well, how hard can this be? Let's just go ahead and stand one up. These things are sitting out there in Hugging Face. I download it, put it on VLLM, and let's see what happens. There is a lot more to consider in it. And probably like the easiest bar for entry here is if you're an organization that most of your IT operations are being consumed via software as a service or other components, you're probably going to struggle to stand up an AI platform and run this independent of those cloud services. But if you're a company with an IT organization who today is running some type of platform, whether that's a data platform, an application platform, or anything else, like they're very similar to running an AI platform. So you're going to have a lot of the core principles and capabilities already in your team, right? Things to keep a mission critical application running 24/7 are very similar to running a model 24/7. There's a lot of the same considerations when it comes to lifecycle, right? So companies who can build and maintain their own application base and lifecycle those and secure them, same concerns come in with models. You have to be able to retrain models. You have to be able to test and validate models. You have to be able to roll them out. You have to be able to monitor and observe them. You have to be able to roll them back. And you need auditability and traceability along the way. So if you've got that principle down, like you're pretty well suited for it. The next thing that I tend to talk to a lot of customers about is around where do you get that AI platform? And prior to the rapid acceleration in the adoption of generative AI, there were a lot of very sophisticated enterprises who were building and maintaining their own AI platform. A lot of the AI stuff that everyone's playing with today has been in open source for quite some time. And if you had the right team, you could actually go and compose your full end-to-end AI platforms, including everything from development to model lifecycle to monitoring to inference and all of those things. But now, like with the rapid pace and the dynamic nature of the AI space, it calls into question whether or not that's the core competency of the enterprise. And so I talk to a lot of companies about whether or not it's still the best use of their time to try to keep up and maintain that platform versus buying an integrated platform like what Red Hat ships, right? We have our OpenShift AI platform deploys right on top of OpenShift. And so if you're an enterprise that's already adopted an application platform like an OpenShift, throwing an OpenShift AI on top of it extends the capabilities that you've already trained your operations team to run with. And the skills are very transferable and allows you to focus more on the value added parts of AI. So like, how are you actually going to put this into the business? How are you going to track and manage whether or not you're actually getting value out of it, manage the life cycle kind of things. So this has been a key consideration. But I will say, yeah, there is sort of this expectation in a lot of customers where hey, like everyone's doing generative AI, like I should be able to do it within my four walls as well. But they haven't necessarily built up the discipline around it. It's not as plug and play as maybe everyone makes it sound in some of the articles you read out there.
Another element of running your own models is the selection process, where there are the big name models that are available in open weights. So everybody has heard about DeepSeek. There's the GPT OSS models. There are the Llama models. So there are a certain handful of model creators and model providers that have gained a lot of visibility, but then there are also numerous derivative models, either of those ones or other models from smaller firms that are maybe not as popularized, as well as the fact that selecting an off the shelf model from a provider that hasn't been thoroughly vetted also brings in a substantial amount of risk because of the potential for being able to actually embed malicious subroutines into that model if you are not doing a thorough evaluation of it. And I'm wondering how you see teams address the complexity of the overall model space in terms of one, identifying what is the actual type of model that I want, because there are different models with different specialties. So, do you want a mixture of experts model? Do you want a model that is optimized for latency? Are you more worried about the context window, et cetera? And just the how you're seeing teams try to stay up to date with the selection process, the model availability, and being able to actually do their own evaluation of model capability as well as the security element.
When it comes to model selection, probably the first thing that comes is like any kind of geopolitical concerns that we see on like which models that enterprises and customers have like approved for use within their four walls. From that, like moving on from that, there's sort of like a popularity factor, right? You can read a lot of articles from other individuals who have played with these models. So you get the big name ones obviously get a lot of the attention, right? So whether it's the DeepSeek, right, or GPT OSS or llamas, there's only a handful of major providers of models that are out there. Now there are a lot of derivative models that get created off of that, because not everyone's gonna, well, practically nobody's gonna deploy the pure frontier model inside their four walls. From there, again, it kind of comes down to use case. So as each new frontier in technology advances, so right when the MOE models first came out, we saw everyone shifting toward MOE models because this was going to solve all of their problems. But then you start to realize that there are constraints, right? And some of those constraints are performance based, some are cost based. And then you start to kind of whittle it down and you see advancements in technology where they improve the internal routing so that a particular prompt will only get routed to the expert that's actually needed versus so it's optimizing across all the different layers. You have the ability to prune certain layers out. But again, these tend to be pretty advanced concepts for folks who are or more focused on like just getting the business value out of a specific model. Then it comes down to like specific use case, right? So now we like obviously agentic has been a very popular trend this year. And so with agentic, right, you start getting into tool calling and the ability for models to be able to take action based on specific prompts. And so at this point, like most of the model, like the major model providers are generally pretty comparable with one another, right? So whether it's like GPT OSS, I'll say has done very very well. Quen has done very well. Llama, it has been previously very very popular, but we're starting to see that fade in favor of like GPT OSS. So I think when you look at kind of the different evaluations that are out there and based on like other people's use cases, I think that's driving a lot of the adoption within enterprises. From there, they'll refine it a little bit more based on their specific use cases. And where I'll see the difference there is if they're self-hosting, they'll tend to do like they'll have their own evaluation criteria. They'll run a set of like tests against various models and they'll repeat those tests to determine which ones are giving the better outputs. If they're consuming like API services, I'll say like a lot of the software as a service providers have put interesting customizations in front of some of these models that do help optimize the outputs of them. And so it's kind of the same methodology of let's take our test framework, run it against these models, see which gives us the relevant results, and then pivot toward that model. The hard thing I think for enterprises is like most of the ones that are adopting generative AI today have a pretty good process around that model evaluation. What has been hard to adapt to is the frequency and pace at which these new models come out. And so, you can imagine, you're just adopting generative AI, you get your first set of agents built, right? It's built on top of a specific model. And then like the next new model comes out and now you have to life cycle and retest the whole thing. That rate of change has been a challenge for a lot of enterprises to be able to absorb. But a lot of this is just driven based on use case. And again, as these come out, they certainly get a lot of press. So there's no shortage of information to consume.
As you mentioned, agentic use cases have gained a lot of the attention over the past several months as the models that are available have become more capable of things like tool calling and planning. In that agentic context, there's also the potential for having multiple models operating in concert, where maybe you have a larger model that acts as the planner and orchestrator, and all of a set of smaller models that are doing the actual specific task execution, which also adds a little bit of nuance to the selection process. And I'm curious how you're seeing organizations work through some of that complexity and the evolution that they go through as far as their adoption of agentic use cases, where for the first year or so, the killer app of AI was, oh, I can talk to all of my documents and I don't have to read them all. And so now we actually have things that are able to do more value creation, but they require a much higher compute capacity because of the fact that these models are running for longer periods and consuming more tokens. And I'm curious how you're seeing teams think about that aspect as well, as far as the financial elements of, I can use a larger model, it's more capable, but I can also run 5 smaller models for the same cost, and maybe I can split the tasks out among them.
Yeah, the world of agentic and kind of where it's heading right now has been probably the most exciting part of for me about what's happened with generative AI. Like models always existed and models always gave people answers, right? And it used to be individuals had to determine if that answer was valid or invalid. But it when you start talking about agentic, like this improves the overall accessibility and the value that AI is going to provide. And kind of the evolution of it going from like one agent that does a series of complex tasks has now broken out into kind of a more service oriented architecture where you have individual agents who specialize in specific tasks and then they coordinate amongst each other to solve much more complex tasks. And I love that architecture, by the way, right? Because it helps to distribute some of the responsibility to organizations who can specialize in that specific discipline. And so they can make the best possible agent for whatever that task is. But it does introduce exactly like you said, hey, do we have all the agents just work with one big model? Or do we have smaller models tailored towards specific tasks? And I love looking back at historical predictive AI use cases for this because there was never a point where within an organization there was one financial model that did your fraud analysis, provided your financial outlook predictions, and did your budgeting for your like internal departments. Those were individual models specialized for specific tasks and optimized for specific outcomes. This is the world we're moving toward with generative AI and agentic as well. And so while starting with a frontier model to test an idea and validate it and kind of then work down toward a smaller model is the pattern I think we're going to continue to see. And so internally, like again, like what we do is we'll take it down to the smallest possible model for a given set of outcomes. You don't need a model that can necessarily translate into 15 languages if you just need it to crunch numbers and provide recommendations on financial outlooks, or right, or summarize specific like financial reports. So there's a lot that when you look at like the multi-layer MOE models and what's been trained into a lot of these frontier models, it's okay if you regress or lose those capabilities because you're only focused on a specific set of tasks for that agent. And then how they work together, the sum of the parts, right, is what you're really concerned with. This allows, like you said, to drive costs down, right? So from a token perspective, you're going to get it down to the smallest possible footprint. From a resource utilization, this is where sharing across multiple GPUs and maximizing like GPU throughput, so even like fractions of GPUs, is going to matter here. Because again, when this stuff first rolled out, you would load a model up into memory. And I remember our CIO coming to me like, hey, we loaded a model into memory. It was out there for people to use, and everyone was clamoring to use this thing. And a week later, I get a phone call and it says, I don't understand what you're doing. We're spending X amount of dollars a day on this thing for you, and it's sitting 68% idle. And basically, like, you weren't able to share across tasks, right? So if we needed two models, it would just hold this memory and the GPU, static. And if someone was hitting one, right, great. Like if they're hitting the other, great. But there was no sharing of resources across the two. That's all been improved now, right? So where you're actually able to maximize GPU utilization. So there's a lot that's been built into the systems to help with these use cases. And there's layers that have been built on top of the agents as well to help with the orchestration. So things that previously maybe had been built into various model routers and whatnot are sitting a layer above it. So I think we are looking at a world where we are going to continue to drive towards smaller models, more specialized models as part of these agentic workflows. You'll probably have like a set of agents that are sort of that task oriented agent. Like you'll get into an area where we have agents that are helping us coordinating, right? So maybe they require a broader knowledge context to be able to perform their function across multiple sub agents. But you're going to see these things fit for purpose versus just the general purpose, like we hope one size fits all approach that got everyone started.
To your point of needing to customize the models for specific tasks or specific problem domains, that has largely been done through post training or fine tuning, which generally requires a decent amount of understanding of the overall model architecture and how to actually do the model training. And I'm wondering how you're seeing the complexity and difficulty of that process change, particularly over the past couple of years that this has been in very active use.
Yeah, this has been an area of rapid development. So again, like going back to when I started, you had people who went to school to become experts in being able to do analytics. The languages were tailored toward those experts. Those experts knew how to interpret the results. They had a set of specific tests they could run to validate whether a model performed the function and confidence intervals and things like that. So like it was a highly disciplined field that then only when they were comfortable they would make that model generally available to the public to consume. And the public didn't concern themselves if the model was doing the right thing or the wrong thing because the expert had blessed it and said that it was. When you look at it now, like the availability of frameworks to be able to customize models, tune them, and then serve them has really, like the ease of use has dramatically advanced to the point now, like if you look at kind of what we're doing with the Instruct Lab community, we have a set of components and an SDK that allows you to do things like synthetic data generation. So if you don't have millions of rows of clean data at your fingertips and you only have a handful of rows, you're able to take that and use synthetic data generation and then influence one of these larger models to understand your use case better than it did previously. So the bar for entry on data has been lowered. The different types of tuning frameworks, right? So whether it's SFT or LoRa or these, like all of these are now more available too and very easy to integrate into these workflows in a modular way. Serving has gotten down to a one-line command, right? VLLM serve and give it your model and it'll stand it up. So I think like there's been a huge push toward accessibility and making these frameworks more performant, more easy to use, and more universal in the types of models they can work against. But with that easy use comes the challenge, right? Like with that accessibility, no longer do you need to be an expert in understanding how what's going on behind the scenes when weights are created and how models actually compute and work their way through the neural networks, which means like at the end of the day, like again, these models are always going to give you outputs. That's what they're great at giving you answers, and they sound very confident in all of those answers. But I think we're lacking a little bit on the guardrails and safety and evaluation side of things right now, where people are putting models into production that because the job ran, they think like, well, hey, it ran, it must work. It used to be like if my code didn't compile, I knew that program didn't work. But if it compiled, like, hey, pretty good chance it did what I asked it to do. Like, that's where I think the next round of development has to occur so that we don't want to reduce the accessibility of being able to tune these models, but we do want to increase the confidence that people have with rolling them out and putting them into production.
On that point of the evaluation harnesses and the guardrails and some of the other operational requirements, even beyond just the hot path of serving a model, what are some of the other infrastructure and organizational capabilities that teams need to be aware of as far as being able to run a true production grade LLM or agentic system that are maybe below the waterline in terms of their initial evaluation and initial development path that become evident as they actually start serving these things and relying on them in an organizational capacity.
Yeah, there's an interesting expectation. And actually, I think there was a recent report that came out from MIT that got a lot of attention that talked about the high failure rate of generative AI projects within enterprises. So like anyone doing DIY, I can't remember the exact number, but like let's call it greater than 90% of these projects fail. And I think this is something that if you haven't worked in this space sounds it sets off alarm bells like, oh my gosh, like that's a really terrible thing. But the reality is like AI, predictive AI, generative AI, like they were always experiments, right? And so you always have a hypothesis. You're using data, you're encoding that data into a model, and then you're validating and testing the model to test your hypothesis. And this was expected, right? And then it was a rinse and repeat type workflow. Like this is where the whole ML ops workflows came from. So the expectation was that you would iterate over multiple experiments to arrive at the best possible result. And I think this like concept is lost in a lot of what we see with generative AI and some of the publications that are out there, that it's just sort of a foregone conclusion that of course it works. And if it doesn't work the first time, then it probably wasn't done right and it's an absolute failure. And that's not the case. Like I think a lot of enterprises miss the point behind it's that rapid iteration that's actually going to get you the best result. It's not always having the smartest engineers or the best data, but it's those who are able to put it into a repeatable life cycle and iterate rapidly to test multiple hypotheses that will arrive at the best possible outcome. That coupled with the idea that a model is a one and done thing is also dangerous, right? Because things change, right? Financial economies change, all kinds of products change, customer support trends change. So your ability to continuously retrain that model, reevaluate it, and put it into production, like that's going to be a key element of success. And I think these are a lot of the things that people don't account for upfront, right? They think about it as less of a living thing and more of maybe like a slowly life cycled application that, hey, once I get it set, it'll live for a 6-9 month life cycle, 12-month life cycle, and then I'll have to go provide some updates. But that's not the case. Like if you're running a very healthy like AI organization and workflow, you're training models nightly, you're evaluating those models nightly, sometimes multiple times per day, right? Based on like as data's arriving for some of these more real-time workflows. Like imagine you're trying to detect defects on a factory floor line, right? You're not going to train once based on 10 years of historical defects when you have a new product line coming out and expect it's going to detect all the right defects. You're going to want to get real-time input from folks working on the factory floor and retrain models based on that input and deploy those quickly. It's that overall life cycle that I think gets underestimated in a lot of cases.
The other aspect of customizing models is that maybe if you have a very specific use case, there isn't an off the shelf model that has enough out of the box functionality. And so then you're down the path of, well, maybe I need to train my own model, which is another interesting heuristic of one, do I have enough data? How do I decide that? And two, do I have the technical and organizational capacity and know-how to be able to actually develop and train and build that model? And I'm curious how you're seeing teams think about that as well, where do they have enough data or a unique enough problem that it is worth the time and financial investment to actually create their own model from scratch versus adapting something that they can pull down from Hugging Face, etc.
Yeah. And this is one like I even in my personal like I use this sort of heuristic as well, which has generally been the like, look, if time has value, right? Your time has value, my time has value, everyone's time has value. And if I'm asking a question or proposing a problem to a model that is easily solved with like an off-the-shelf service, I'm going to use that service, right? So hey, summarize my email inbox for me. Hey, summarize a set of documents for me. I don't need to tune a model for that because it's going to take me at best hours, more than likely days to be able to tune that model. And I may or may not get as good a result as like one of the public services would give me because it's like there's generally available data that these models were trained on. So they're very, very good at those things. when it comes to something specific to your organization, like we have seen an increase in a premium put on AI engineering skills. So because enterprises have started to realize that they need some expertise within their company to be able to produce these models. I'll say like there's an expectation that your general developer though, with the advancements that have been made in the various toolkits, that the general developer should be able to actually customize models as needed under the guidance of like these AI engineers, right? So it's not necessarily just the Wild West, but there's somebody to bounce the ideas off of and to kind of validate the process and procedure. A lot of like the barriers for entry that used to be sort of like the data quality problem or the data volume problem to be able to move like the weights on some of these models, there's been tremendous advancements in the synthetic data generation. So we have some out there in our Instruct Lab project. NVIDIA has some great SDKs and they have like NIMs available for synthetic data generation. There's a number of like open source projects that are have launched around this as well. And so where these constraints have existed, open source has done a great job of kind of rallying around them and helping solve them in very meaningful and effective ways. And now what you're seeing, again, it used to be that even where these things were solved, the workflow that incorporated these components was highly prescriptive. And so they didn't have a lot of exit points or customization points for you. Now you're seeing again, like, so like what we've done with Instruct Lab, we're distributing it now as an SDK. So it gives you the ability to use like our synthetic data generation with somebody else's tuning library, right? So you're able to mix and match components from different ecosystems to provide the best possible outcome. The thing we haven't necessarily been able to solve for effectively is just the overall like resource constraints when it comes to needing GPUs to be able to solve these things, right? If you have access to maybe earlier generation of GPUs, you may be waiting weeks for your result. Whereas if you have access to the newer generation, you may only be waiting hours. That's still a constraint that like there are the different fidelity options you can use to kind of test things early on. But for your final runs, things have advanced, but we don't have a great answer yet for some of the long running routines that are required here.
The availability of hardware is another interesting constraint that I'm curious to get your perspective on how that also influences the size and complexity of model that an organization wants to use, where maybe if they could get hold of a certain grade of GPUs and a high enough capacity to be able to install into their own data centers, they would go for the biggest, best open weights model. But because they're constrained to a previous generation of hardware, because that's what they've already spent their capital budget on, or because that's the only thing that they're able to get in a large enough quantity for their intended deployment size. So maybe they need to scale down the size or complexity of the model. And I'm wondering how that factors into the overall calculus of what they're trying to do and how they're trying to do it.
Yeah, it definitely factors in. We've seen it factor in like one in just increased requirements that we get from customers around things like model as a service and GPU as a service. So they have limited number of accelerators across various generations. They want to maximize those as best possible. And so what used to be sort of a hard and fast allocation algorithm of like team A is using that particular GPU, it's locked until team A is done, has evolved now to a more, GPU as a service or model as a service where you're providing the access, but the access is more fluid, like how we would over provision and manage VMs in previous generations of technology. So there's been a lot more emphasis on being able to optimize those types of requirements, right? Being able to also have priority and preemption in various jobs. So if you have a high importance inference routine running, like that may take priority over a very long running training job that takes multiple days so that you're fielding requests in the right order. The other thing we're seeing is much more emphasis on being able to profile model performance across different accelerators. You're seeing like there's other entrants obviously into the accelerator market. I think I mentioned earlier, you can run small language models on like Xeon processors as an example, right? So there are some of these components within data centers today that customers are asking us, to profile and say like, hey, just how good would it run on this thing? Because it might be that the latency required or the time required fits within the quality of service that can be provided by that accelerator. So we've spent a lot of time like internally, I think a lot of enterprises like, software developers, model developers were profiling models this way anyway. We just weren't making all of the data public. As part of like what we're rolling out, we're actually going to be giving the evaluation frameworks and performance frameworks to customers. So as they customize models and they want to profile them to see which types of like how they would perform across different hardware and accelerators, they're able to do so to help maximize their own throughput and cost analysis there as well. So everyone's heading this direction. And again, like you're seeing it worked on from both sides, software, hardware, models. Like everyone understands that in order for generative AI and AI as a whole to kind of take hold and grow, it's going to have to become a more cost effective, efficient process.
And as you have been working in the space, working with customers, helping them determine the appropriate model selection criteria, evaluate their own technical capacity for actually deploying and maintaining these various models or develop agentic use cases, what are some of the most interesting or innovative or unexpected ways that you have seen organizations capitalize on the efficiency and deployability of these smaller models?
Yeah, I like this one because like there's always like you right. I followed the industry quite closely, and you hear all these like the fears that AI is gonna take over the world, ruin quality of life. So I tend to kind of emphasize more the ones that are good for humanity, and some of the more interesting ones I've seen have come out of like the telco space where they have agents that in real time can flag AI generated voice calls, right? To help with consumers being able to kind of detect and identify scams, right? That are emerging where these folks are able to emulate the voice of specific contacts that are personal to that individual to be able to like exploit it in some malicious way. So having an agent that can flag for the individual that this is an AI generated voice is a great way of helping protect folks, right, from some of this technology. The other one I love is around like this real time voice translation that I'll actually do language translation for you. So if I'm communicating with a colleague in France, I can speak in English in real time. It'll communicate in French using my voice. This is another one. Like I tend to use my kids as a barometer here. And when I come home and I see my kids playing with a specific technology, that means it has reached the bar of accessibility that, hey, like a preteen is able to use this, and it's also exceeded the bar of usefulness in that they're actually getting value out of it because they have friends in their school now, right, who are speaking multiple languages and they're able to do this. So I love looking at those things because we're a global economy. It's great to be able to connect to people that way. I don't think this one's so much like unexpected, but the thing I love now on like the agentic workflows, we moved away from sort of this monolithic agent who does everything into creating specific agents that represent specific workflows. And now, like on my team, and I've seen this in other engineering organizations, we are building agents that basically reflect an individual persona on a development team. So we have an agent who reflects like our product owner, and one that represents our UI engineer, and one that represents our dev test ops engineer. And we're able to build these into workflows to be able to arrive at like better defined requirements with better design specs that then we can auto generate the code for. And it's just great to see how we've been able to encode years and years and years of expertise into a meaningful way that is actually improving the quality of life for our individual engineers. Again, everyone thinks it's going to take away their job or fears that it will take away their job, but that's not the case, right? What it's doing is giving us such a better starting point that we're able to run again multiple experiments, try out different user experiences, have agentic users try them out and give feedback on that we're getting to better products and we're getting to better quality, which is ultimately what like anyone who's building software like in my role wants to do. Like we want the best experience, we want the best quality, and this is helping us get there. And so again, I don't think that one was unexpected, but when you see it play out and just how effective it is, it really sets off a lot of lights in your head that like, wow, this has real tangible value to a lot of organizations.
And as you have been working in this space and helping teams get up to speed and build capacity for being able to do that model selection, customization, deployment, manage the overall life cycle, what are some of the most interesting or unexpected or challenging lessons that you've learned personally?
Personally, like so again, having worked in the space for a while and kind of lived through the evolution of how data and model development's advanced, it's impressive to me to how, again, just how accessible models and model customization has become. The things that exist to help with data generation and model tuning and how easy that has, it's just phenomenal. Again, like these used to be teams of 2 to 3 people in large organizations who would produce these models, and now you're basically turning it loose so hundreds and thousands of engineers within an organization can do it. Like that is, to me, just phenomenal. Now, I mentioned a little bit earlier, like what it has impressed upon me though is the need for more comprehensive testing and evaluation to be able to help with the confidence level and quality of these models. Like we've made the training and development really, really easy, but I don't think we've necessarily done a great job improving the test and evaluation to ensure quality of output here, which can get a little scary, right? Because if you've ever talked to one of these models and you've ever gotten the wrong answer from it, you'll know it does a great job of sounding quite confident in that response, even though it is incorrect. So this is an area I focus a lot on in areas that I'll contribute to, is helping make sure that like this level of confidence is equal to the ease of use that's been developed out there. Because again, like when I look at potential pitfalls, on why AI adoption may not take off, this would be one of them, right? If you lose confidence that your model is actually going to give you the right response, you're not going to keep investing in it, right? You're going to throw it away and go back to what you used to be doing. And so ensuring that we've got that worked into the systems for folks, to me, is a key input we need.
As you continue to work in this space, keep track of the overall industry and how things are progressing, what are some of the predictions or expectations that you have for the near future, particularly in terms of the ecosystem of small language models and their overall capabilities and applicability?
I think you're going to just continue to see a drive toward efficiency, resource efficiency, cost per token efficiency, idle resource optimization, ease of use and consumption, being able to drive this down to the point where you can run a full end-to-end workflow on your laptop. If the barrier for entry is having millions of dollars in a data center to be able to get this thing to actually provide you value, like that's a barrier that not every company out there is going to be able to overcome. And so I think that's where you're going to see the greatest advancements.
Are there any other aspects of the work that you're doing in this space, your overall perspective and experiences around small language model utility and the organizational and technical capacity to facilitate that we didn't discuss yet that you'd like to cover before we close out the show?
The thing I really like, so the area that also excites me, so when you start thinking about the challenges of agentic workflows, so we've talked about how like my team has sort of been codified into a set of agents, and I think right now, like across our entire team, we have 30 or so different personas, which is still relatively manageable. Like I can keep most of them in my head and keep track of which ones we've updated and not updated. But then if you were to extend that across multiple departments, across an entire company, that gets you into the hundreds and potentially thousands of agents. And so agentic management and agentic workflow is going to start to become a real consideration here. This is an area that I watch with like excitement as well, because how you start to manage like a catalog of agents, and just like things we did with like Docker, like how did we manage the catalog of containers that were out there, and how did we know which containers were the best possible containers, and like that sort of ecosystem is what I think we're going to start to see evolve for agents, both on like a commercial side of agents that are provided by specific vendors, but then also internally for homegrown and DIY agents, and how these things are managed together. That to me is an exciting area, because when you start to get to that level of complexity and adoption, then you've got a technology trend that has legs and is going to take off. And again, having kind of dedicated 100% of my professional career to this space, it's exciting to see just how popular this stuff has become.
All right. Well, for anybody who wants to get in touch with you and follow along with the work that you're doing, I'll have you add your preferred contact information to the show notes. And as the final question, I'd like to get your perspective on what you see as being the biggest gaps in the tooling, technology, or human training that's available for AI systems today.
Yeah, I'm going to go back to my I think I've said it a few times in here, that whole guardrails and evaluation for folks, like to me, that's the one we've got to get right. Because again, everyone's getting good at training models. They're getting really good at how to prompt models, and they're getting good at what they would expect out of a model. But if we don't add the right guardrails and add the automation that helps evaluate and make it super simple, determine if your output is valid or not, we're going to have a lot of struggles in scaling this across the enterprise. So that's the one I would love to see serious investment from a lot of the AI leaders in.
All right. Well, thank you very much for taking the time today to join me and share your thoughts and experiences around the selection and operationalization of these various model sizes and how to think about incorporating them into these various use cases. It's a very interesting and constantly evolving space. So I appreciate the time that you're taking to help other teams get up to speed with this and the work that you and the Red Hat folks are doing to simplify the operationalization of these systems. So thank you again for that, and I hope you enjoy the rest of your day.
Thanks for having me, Tobias.
Thank you for listening. Don't forget to check out our other shows. The Data Engineering Podcast covers the latest on modern data management, and Podcast.init covers the Python language, its community, and the innovative ways it is being used. Visit the site to subscribe to the show, sign up for the mailing list, and read the show notes. And if you've learned something or tried out a project from the show, then tell us about it. Email hosts at aiengineeringpodcast.com with your story.